Welcome to the Optical Diagnostics Lab of the University of Cyprus. When light interacts with human tissues or other living organisms, it is altered in ways that can reveal underlying pathologies or pathogenesis. The researchers, engineers, scientists and students of the Optical Diagnostics Lab of the University of Cyprus are dedicated to harnessing the power of light for better diagnosis and more accurate prognosis of disease. This research aims at combining microstructural imaging with biochemical spectroscopic analysis and advanced machine learning and artificial intelligence algorithms to enable faster diagnosis and improve the survival of patients suffering from cancer or infectious disease. Optical coherence tomography, or OCT, works by detecting infrared light reflected from tissue and determines the depth of its origin within the tissue by comparing this light with the light reflected from a mirror. If the light beam is scanned over the tissue, it can be used to create three-dimensional images of the tissue microstructure. The Optical Diagnostics Lab has developed novel techniques to extract useful information from OCT images, such as the dispersion and index of refraction. These features, combined with advanced image processing, can effectively detect cancer in a variety of organs and possibly determine its aggressiveness and the patient's prognosis. In a pilot study conducted by the University of Cyprus and the Nicosia General Hospital, the proposed technique has been shown to detect cancer in the gastrointestinal tract with more than 90% accuracy. When light hits molecules in tissues, its spectrum of wavelengths or colors can change depending on the molecules it has encountered. The detection of light reflected at different wavelengths, called Raman spectroscopy, can be used to determine the biochemical composition of the material under investigation. Unfortunately, the light reflected back with a changed wavelength is very weak. However, the intensity can be enhanced if the molecules are in close proximity with gold or silver nanoparticles. The nanoparticles, which are more than 100 times smaller than a human hair, can be excited by a laser and vibrate, resulting in highly bright light as seen in surface-enhanced Raman spectroscopy, or SIRS. The Optical Diagnostics Lab has employed SIRS for the diagnosis of urinary tract infections. Usually it takes 24 hours, using urine cultures, to identify whether bacteria exist in urine and confirm the diagnosis of a urinary tract infection. Furthermore, it requires another 24 hours and another culture to identify the most appropriate antibiotic to fight the disease. The lab has shown that, using SIRS, the bacteria causing a urinary tract infection can both be identified and their sensitivity to antibiotics determined within 2 to 4 hours with an accuracy of more than 85%. In order to fully utilize the data generated by the lab, as well as achieve the most accurate diagnosis and prognosis, the researchers employ advanced machine learning and artificial intelligence algorithms to better explore, exploit, and understand the data. These techniques include support vector machines, ensembles, and deep neural networks. Please feel free to contact the head of the Optical Diagnostics Lab for more information or to learn more about exciting new research.